Das hier ist unser Schlemmraum. Schlemmen ist ein Verfahren zur Reinigung von archäobiologischen Resten, wie botanischen Makroresten, Kleintierknochen oder Insektenresten von feinkörnigen Sedimentbestandteilen einer Bodenprobe. Als Nebenprodukt in Anführungszeichen finden sich in den Proben oft auch archäologische Artefakte wie Münzen, Schmuckperlen, Silex-Debitage usw. Halbflottation ist die einzige Schlemmmethode, welche fragiles archäobotanisches Material nicht beeinträchtigt oder sogar nachhaltig schädigt. In diesem Film wird der generelle Umgang mit archäologischen Proben sowie die Methodik der Halbflotation vorgestellt. Als Beispiel dient eine Probe aus Feuchtbodenerhaltung. Prinzipiell kann die Methode für alle möglichen Sedimente angewendet werden. Wir raten von der Anwendung maschineller Methoden ab. Bigna Steiner, Doktorandin hier bei uns am Institut am ipna, wird uns nun im Folgenden die einzelnen Arbeitsschritte der Halbflotation zeigen.
A waterlogged sample of the late Neolithic lakeshore site Zugried Mat serves as an example to show the washover process. Each archaeological sample should contain a label with the abbreviated name of the site and the sample number. To all parts of a sample, such a label has to be added. Labeling with a pencil is most durable. Here you can see the position of the sample to be sieved in the profile of the excavation and in the profile column. It is best to store the sample wet, but not standing in water before the volume measurement. In some cases, a macroscopic description of the sample makes sense. For this, the material is spread in a large tray. The content of organic and inorganic components, the matrix and the color are estimated using a predefined scale. The reaction of the sediment when hydrochloric acid is applied is measured, ideally in several places. Results should instantly be typed into a table so that this information can be used later. If necessary, one can now separate reserve samples or subsamples for special investigations, for example geochemical, palynological or parasite analysis, using a riffle box or using grid subsampling. A riffle box does not work well for subsampling wet clumpy material, which is why we use the grid subsampling here. The volume of the subsamples has to be predefined or measured after taking subsamples. Then the volume of the sample is measured. The displacement method is well suited for this. A known volume of water is poured into a container with a liter scale and then the sample is added. The volume is measured and the known starting volume of water is subtracted in order to determine the displacement volume of the sample. For this method, the degree of water saturation of all samples should be similar. After subsampling and calculation of the volume, the sample is soaked in water, frozen and slowly defrosted. This process will simplify handling during the sieving process without damaging the remains. After these pre-treatments, the sieving can be started. The procedure and methodology should always be precisely recorded. For this, a sieving journal is useful. There, one can also note important information about a sample. A sieving journal is best managed in an Excel table, but can also be done in a notebook and transcribed later if computer equipment is not available in the lab or in the field. A sieving station consists of 4 elements. The base element, or collecting tank, which holds back fine particles, but discharges the water via an overflow through the pipes visible here. The remaining 3 elements contain 1 sieve each. The smallest meshed sieve is in the lowest element, the medium meshed in the middle, and the largest meshed sieve is on top. Sieve mesh sizes have to be defined beforehand. The smallest mesh size of a sieve is defined by the purpose of the analysis. If lakeshore vegetation with all its small seeds is to be reconstructed, one has to use a mesh size of a widest 0.2 mm. The sieve mesh sizes used here for the organic fraction of a Neolithic sample are 4 mm, as trap for larger remains, 2 mm and 0.35 mm. This should normally be small enough for archaeological research questions about the community's economy. Now all 4 elements of the sieving station are assembled in order to sieve the sample. The original sample is best sieved without subsampling, except for other disciplines, and is only subsampled after sieving, as the clumpy waterlogged sediment could otherwise cause bias in the results. Further items needed for sieving are one or several large bowls, and a funnel with its narrow end cut off for the transfer of the fractions at the end, a small bowl for the sieving of the sample material, a container for the inorganic material, a spoon for the sample material, and a hose with a sprinkler head. Washover is based on the principle of organic remains being lighter than inorganic components of a sample. Using a stream of water, organic remains can be made to float and can then be decanted over the set of sieves. The difference to classical flotation is that the process is done manually and can be controlled at all times. The precise procedure of the washover sieving is the following. Small quantities of the soaked archaeological sample are put in a small bowl. With a stream of water, which should not be too strong, or with a movement of the hand, the material in the bowl is swirled. The components floating on top are decanted over the set of sieves. Those are mostly the light organic components. The non-floating inorganic components are collected separately and, if needed, can be sieved in a second step. Now patience is required while the whole sample is sieved in several portions using the washover method. We will show only some excerpts of the whole process. The sieving process for a sample of this size, with all necessary steps shown in this video, takes about 3 hours on average. Conspicuous and very fragile remains should be separated and put into separate boxes. One should also look out for pieces of dung, like the one which can be seen here, as these should not be broken. If the material is hard to separate despite freezing the sample, it has to be disintegrated with a great deal of sensitivity. To do this without damaging the material requires a certain amount of experience. Staff who sieve should always get detailed instructions and continuous feedback about their work, so that quality can be assured and if necessary several sievers can work on the same project without differences of quality. This is the last portion of the sample being sieved. The container of the sample is already completely rinsed and the spoon is cleaned. Here we see the comparatively large amount of inorganic material at the bottom of the sample container. The material is not evenly distributed, which has to be kept in mind. But in this sample, the inorganic fraction in total was rather small. The proportion can vary quite strongly depending on the sample. Here we see the inorganic material of the sieved sample in total. After the sample has been fully sieved, the organic material of each fraction is again gently washed with a stream of water until the water coming out below is clean. The water pressure cannot be too high, otherwise fragile remains will be damaged. Rubbing and pushing through the sieve are prohibited. We start with the 4 mm fraction. A first glance at the 4 mm fraction reveals remains like a peapod fragment, half a sloe seed, a fragment of an acorn, a leaf of mistletoe, a fragment of a beech nut, and a fragment of a hazelnut. Next comes the transfer of the fractions into fitting containers. First, the content of the sieve is poured into a large bowl using a funnel with its narrow end cut off. Attention! There is a possibility of flooding. Now the top element can be removed. The next fraction, 2 mm, is treated the same way. So first it's gently washed. And then transferred into a large bowl. Now the second element can be removed. The smallest fraction, 0.35 mm, is gently washed. And then transferred. We see here all completely sieved fractions. Before transferring the fractions into plastic bags, their volumes must be measured using the displacement volume. The 4 mm fraction serves as an example here. As the procedure is the same for every fraction, we will only show the process for one of them. The material is poured into a small, very finely meshed sieve. For the displacement volume measurement, it is very important to extract excess water from the fractions before measuring the volume in order not to distort the measurement. This must be done before each measurement. After measuring, the volume should be noted in the sieving journal, either directly in the Excel sheet or first on the protocol sheet. After measuring the volumes of all fractions, if necessary, subsamples for analysis can be taken now. As an example, we separate here a subsample of 5 ml of the 0.35 mm fraction, so that this fraction can later be analyzed portion-wise. Again, the grid subsampling and the displacement volume measurement are used. Then the material is packed into plastic bags or screw cap jars. Plastic bags are best closed by the means of a plastic fusion machine. Here the packing of the 2 mm fraction serves as an example. For more stability and mobility, especially if samples are larger than shown here, the plastic bag could be placed in a beaker glass. Organic waterlogged material has to be kept in water. Attention! A label with the site name and sample number always needs to be added to every fraction. Once all fractions are packed, they should be stored in a cool, meaning less than 5 degrees Celsius, and dark environment until they are analyzed. They are best placed in stackable boxes, which are labeled according to the samples they contain, so that the samples can quickly be found for analysis. The inorganic fraction is now also sieved, but using the wet sieving method. The material is directly spread on the uppermost sieve and is rinsed with a stream of water, which should not be too strong. For the inorganic material, one doesn't necessarily have to use the same mesh sizes as for the organic material. This has to be discussed from case to case with the person responsible for the small animal bones. For waterlogged material, normally 2 and 1 mm mesh sizes are used. The inorganic fraction of the previously sieved sample is comparatively small. Therefore, we show here examples of inorganic fractions from other samples as well. After sieving, the inorganic material is slowly dried and stored, again with a label with all the important information about the sample. Here we see some archaeological artifacts and other finds from sieved samples, such as fragments of bones, fragments of iron, glass, more fragments of iron, a drop of glass, mollusks, flint flakes, and fragments of ceramic.